about the Fortis technology that I developed over the last 30 years, and then talk about the development that we're looking for funding, and hopefully figure out how we can be funded. I was born and raised in the Canadian Forces until 1994. I came back to Edmonton, went back into the family business, and the family business was mainly light gauge steel studs drywall on one side, and then development on the other side, mainly multi-family and apartment buildings. But I wanted to do things differently. I wanted to mirror what I learned in the military, mirror what I learned from school, university, and what I learned growing up, and making light gauge steel as the backbone. So we developed a system where we used light gauge steel from 20 gauge to 6 gauge to basically build multifamily buildings off-site. In 1995, we did our first building, and because I know you didn't see the video, we'll run through a short video after this. But in 1999, we did our first building using a light gauge steel, but it was done on-site. The intention was just to learn the technology, make whatever mistakes we needed to make, grow from that, and then develop from that. After that building was built, we worked with OPEGA, which is the Professional Engineers Association in Alberta, one director in particular. Then robotics a little bit to learn to develop framing systems. And then we moved to University with Concordia to do data mining. So we were able to bring in the information that was done off-site and on-site into one area. And then presently with the University of New Brunswick and the National Research Council of Canada, we're doing some innovations, and National Research Council funds some money for some products that we do. So as we started to develop the system, we put the patent in 2006. It got approved in 2012, but we grew away from the patent. And what the idea was to be able to use light gauge steel as a backbone because of its seismic capabilities, weight to strength ratio, and speed of construction. So we devised a system where we can build wall and floor systems to erect the buildings on site. And since 2005, right up until 2014, we continued that system. We were building many buildings. And the video I'll show you is a particular area in downtown Edmonton where we did some of the buildings. The speed of construction was doing well enough. The exterior of the walls we designed to be thermally broken completely, that by 2014, Great West Life in Canada, in partnership with the Ontario Teachers Pension Fund, got wind of what we were doing in Edmonton and wanted to buy one of our buildings. It was called Fusion on White. It was 650 feet long, 4 stories tall. It wasn't a tall building, but it was really long. But they liked what they heard about the technology, so they wanted to purchase it. They asked us to do 2 things. We had to certify the building to have an actual sound rating done on-site after the building was finished, and they wanted us to have some sort of a certification for energy rating. Now, we've never done energy rating before. We never did any sound ratings before, but we knew the buildings were soundproof. In fact, I lived in one of the buildings for 6 years to see how it handled itself. So we found that the utility costs for the buildings were much lower. We didn't intend to do it green or energy efficient. It was more because of the steel is like 400 times faster in transmitting heat or cold, and we wanted to prevent that. So we thermally broke the building. The other thing we did is we found a way to soundproof the building. So the Ontario Teachers Pension Fund hired consultants, engineers, architects, project managers, to watch us build the building for 9 months. We succeeded in the building, we completed it, and they closed on the purchase of that building, but they wanted us to do those 2 tests. The sound rating we got was better than concrete, and the building envelope engineering model for energy efficiencies, we got Built Green Silver, which at the time was the second highest. Today it's the third highest. So we're pretty happy. We started to improve the building technology. So I'll show you two videos of actually how it's an animated video of how the building process happened offsite. And then I'll show you the future of what we're hoping to do with the Fortis technology.
You have a machine that starts with strip stock and punches it out and forms it on site? Okay.
No, it forms it off-site. Everything's off-site.
That's what I mean, off-site, yeah.
Yeah. I need somebody to give me the power to take control.
Ask Lori politely. Maybe
Lori,
she'll acquiesce to us all.
Can you please help me out?
Absolutely. Hold on just a moment here.
The small Fortis plant. This is the one that we had where we started building, but it gives you a nice detail of what. So of course we bring the material in, and the first set of material we have is the coil. And with the coil, we would start, depending on the design and engineering we do of the buildings, we take the different gauges of steel, and then we would roll form them to the specific sizes. So this is an example of the machine that was bending the steel depending on the gauge we were using for the wall and floor assembly. We would stockpile the steel ready for the next performance, which was the framing side. And we'd grab from stock the particular materials that we needed to start the framing. And we'd use our BIM modeling for the buildings that we built to know how to take the material and how to detail the connections. So these are the packages that we would use before we would frame the wall. We use this machine that was between 4 feet to 16 feet tall and 20 feet long, is where we would frame the walls and the floors. And we'd use a nailing, actually screwing details where we ended up using. We tried welding, that didn't work out. And we tried nailing, that didn't work out, so the screwing was the best. So we would flip the wall. If it was an interior wall, we would flip it and send it to site as is. And we generally be able to erect 3 suites a day, which is about 650 square feet each unit. Now, if we had to treat a wall where we had to do an exterior type wall, we would sheet it. We would put an air vapor barrier coating on it to seal it. Then after we've done that, we would flip the wall, and then we would treat it with insulation, where with interior or exterior insulation, we opted 99% of the time exterior insulation, and then we'd finish the coating of the exterior, which we were able to do any type of exterior surface except full face brick. It wouldn't transport easy, so we used brick veneer instead. So once we were done, the walls are ready to go. It takes 4 to 5 days, depending on the type of material, and then these walls will be shipped to site to be assembled. So on site, the buildings could be 2 to 3 units completed in a day. But what we found over time is that the plumbing and electrical didn't keep up with us. So we started building bathroom pods, but not the bathroom pods that were, the inside is finished, but specifically the actual plumbing was done. So by the time we finished the roof on the framing, the plumbing and electrical was completely done because the kitchens were plumbed and the bathrooms were plumbed. So because of this, we decided to design a new type of manufacturing facility where it's advanced. And this one here, I'll do very little talking. Same idea, but mass production.
So you build them with exterior walls, but not interior, so you can get the plumbing and electrical through, correct?
Now we build them exterior and interior, but for example, the bathroom pod, we would drywall the inside space inside the bathroom, but leave the outside. So the site inspector didn't have to remove anything and inspect the plumbing.
So how do you install the electrical and plumbing through any of these existing walls?
So most of the walls, so if you talk about the plumbing, we have a special detail for the bathroom pod. So the bathroom pods stacked on top of each other like Lego, and the plumbing would be easily visible from the suite below or from the side, depending where we put the plumbing. If it came to electrical,
yeah, you've got convenience outlets strewn around the wall at different places. Where do you incorporate those? You get the electrician has to do a cutout on the wall and then drop it in that way?
no. If the intention is to complete the drywall phase off-site and bring it on-site, the bathroom ceilings and the suite ceilings are not drywall. So all the conduits are exposed from the ceiling side and from the outlet side. So if we drywall the unit, but if an electrician or the site inspectors didn't want me to cover the wall, we'd always cover the one side out of the two sides of the suite. So the electrician, the city inspectors would come in and they could see all the plumbing and the electrical as well as the fire rating off of one side of the wall.
Yeah, I would expect they typically want to do that after the electrical and plumbing are done. They're going to check for it,
So in Edmonton, every city is going to definitely want that. In Edmonton, because we did it so much, the inspectors would come to the manufacturing facility, for example, and they would do the inspections there. And it was easier for them, it was easier for us. Over time, they didn't inspect what was in the walls because our quality control was high. Today, there's a company in Canada called Intertech. Intertech will do inspections on behalf of the municipality or the regional inspectors, as long as we have a coordinated inspection plan. And they would come to the shop, inspect the particular plumbing or electrical, so when it comes on site, we didn't have to deal with it twice over. And the reason it worked out was because we always followed the local building code. So we would design the building to not require certifications in the wall and floor assembly. So we followed the building code. That's what we started in Edmonton. We found it worked out good. The connection details were unique. And it also prevented us from requiring special certifications when we moved from one region to another. We were able to follow the building code. And luckily, most of the code in the world is some part of the British code or the International Building Code. So there's always a connection somewhere.
Right. So if you're going to sheathe on both sides and you have electrical outlets, you pre-wire it and put the outlets basically in the walls and then bring out the electrical connection to the end of the wall so it can be hooked into the next unit.
That's right. Oh, yeah. The way we treat all the plumbing and all the electrical is very close to called a home run system. So everything is designed to one location in the unit. And the reason we do that is because we incorporate digital metering in everything we do, from even the mechanical room down in the parkade to every suite. So this way we have the ability to monitor the life of the building without having to have large management walking around the building for any issues or having somebody tell us there's a concern. We also got to a point where in the mechanical room, for example, we would have sensors, vibration sensors. So when pumps, for example, vibrated too much, we knew there was an issue. So it would be more of a proactive type management system.
Okay, sounds good.
So that's the manufacturing facility, the technology of which Fortis grew from. We were mainly focused on multifamily and mixed-use development. And since 1999, we tried the system on site, but since 2006 to 2019, we've been building pretty well exclusively with the manufacturing facility. Now we fast-tracked to today. we have a project called the McVean Project. I'm going to first show you the video. I'm not sure if you've seen any videos. Did you want to see videos of a bunch of buildings we did in Edmonton? Just so you see what it looks like.
Do you want to show me? Sure. You know, I haven't had a chance to look at your package yet. So.
Okay, no, this will be, okay, no problem. Then this might be better. So this is a drone video of just a local area in Edmonton. So a bunch of buildings. It just gives you an idea of the level that we can do. And I'll describe them as we go. The first building we ever did using the system, but it was on site, was this one here, Manhattan Loft. Each unit is 2 stories tall, and it was built in 1999. This video was taken in 2018.
Laurie, can you please admit Earl? He got.
I'm not seeing Earl in the waiting room.
This is the one that we had full architectural control over and worked to design the wall of floor assembly that made this building go very fast. This building, we hit the roof in 2 months.
Pretty good.
Yeah, and the city shut us down. And the reason they did is they thought we were there 6 months early. And I only had a building permit for 2 months. So they came by the site and said, there's no way you built this in 2 months and shut us down. So I had to explain to them we built the entire building off site.
Prefab, as they say.
Yeah. This one here was complicated in the fact that this is the first one that we actually did everything inside and outside. Wasn't necessary, but it moved really quick. This is another one we did. We did this all panelized. And sometimes we'll do work for other contractors or developers where we'll only do small parts. So we'll do the walls, the exterior walls, and just do the steel on the inside and leave the plumbers and electricians to somebody else. So we're pretty flexible when we do our wall and floor assembly. So this is one we did where we did the bathroom pods. We did the exteriors, but we didn't do no electrical and no drywall, other than the bathroom pod. So that's an example of the bathroom pod stacking and the plumbing connect from one side. And you can see one wall over there.
Okay, he's in the room now waiting. Thanks. Sorry.
He's not showing up here.
Now this is the one built in 2006. The first time we had the plant operational. This one here took a while. We also learned everything with this one, but we learned it from the plant. So every floor we changed something and educated ourselves how to make it faster, better, stronger. And this was also taken in 2018. It was built in 2006. This is the one I talked about that the pension fund bought. It's 650 feet long. It's only 4-story. And this is the one they monitored the building for 9 months with their own engineers and consultants watching us build.
It's all designed for the low temperature, I guess, right?
Yeah, Edmonton goes from -50 to +40. So we designed it for huge temperature gradient. This is a 16-story we did. This wasn't our building. We built it for somebody else.
I've been there when it was -30.
Yeah,
I
that's not
remember
fun.
that day.
Yeah. Yeah, I'm going to try to find a way to take control again. Okay. Any questions so far?
No.
Okay. So that's the Fortis technology. But we have a product right now in GTA, just outside of Toronto itself. It is 10.2 acres. Right now,
Well, let me ask you some questions on the technology if you're going to go to a specific project, right?
sure, okay, no problem. I'll just get out of it.
Well, just that, no, it's fine. Just a couple questions. Right. What's the delta in cost between traditional construction and what you're doing?
Okay, so every building is different because the interior finishes really don't dictate some of the cost. But if you look at structure itself, we're usually between 30 and 40% cheaper. But we need to be part of the design phase. Most of the time, consultants don't design for speed and accuracy. They take the idea that the stick framer on site makes the fixes. With our situation is we design everything with BIM modeling long before we even frame the first wall. So every wall, every floor dimension has to be accurate. So when we do the designing, for example, I'll give a perfect example. If we just talk about, in Canada, right? Precast wall and floor assembly in Canada, and all they do is load-bearing walls, exterior walls, and floors. So in a suite, they would do the outside wall, they would do the corridor wall, and depending how long the span is, they might have one or two walls inside. They're $60 a square foot. Then you have to bring a framer inside to finish the framing. We are $30 to $40, and it would do everything the panelizer does, the precast does, and everything the framer does. So that gives you a level. And the framer, I mean, they're about $15 to $25, depending how many walls they do on the inside. So if the math on that is like $60 to $70, or $75 if you take the upper end, and we are $30 to $40. That gives you an idea with the framing. Now, the exterior is unique in the fact that you saw the 16-story building. I'll give you an example with that one. We didn't own that building, and all we did for them was the outside. They were on the 11th or 12th floor when we started, and it's 16 stories, and they are red iron steel frame system. Okay, it doesn't take long to do. They were on the, I think, 10th or 11th floor, and we started on the first floor. We had over 1,057 panels put on that building. We finished before they finished the roof. So we left all our walls and floors that we couldn't finish for about 3 or 4 weeks later until they got to the roof on the framing side. Then we finished. And then a year and a half later, we were able to finish the last 40 walls. That gives you an example of how fast we can get on the site and get out. So that building, they never scaffolded to do the outside of the building because we did it all from the inside. All our walls were completely done. All our walls had windows, and everything was installed from the inside. I actually have a video showing our wall, if you want to see it, being installed, but not on that building. It was on a concrete building for a hotel.
Okay, I
You want to
understand.
see? Okay.
I'm an engineer myself, if it helps.
I know.
Right?
I know. That's why I'm happy to answer whatever you want to have.
Yeah,
I warned them.
That's
Oh.
right.
you let the cat out of the bag, huh?
Yeah.
I've had some experience in dealing with steel wall framing structures. There are a number of people, in fact, who have a machine they take on site. They spit each of the members out. They frame them and they cut them the length and the whole bit based on a computer program. So
Yeah.
but then you're assembling on site.
Yeah, that's like frame CAD. I think if you go to Dubai, it's ILS. There's a lot of guys out there. Kumaj is one. We don't do that.
No, you're building them in-house.
Yeah, we found, the building in 2006 I told you, the one that was the big U-shaped one. We found that there was no sense in building a part of the building and watch everybody else come back later on and finish the rest of the building. So we kept incorporating every part of the structure, mainly because we own the building. that we wanted, when we hit the roof on the framing, we wanted to hit the roof on the plumbing. We wanted to hit the roof on the electrical. So we started incorporating other systems off-site. So when the building truly was erected and finished on the roof, so was the main portion of the structure. So all that was left was the inspection and then the drywall. Because the outside was done too. Well, and it sped up the process.
Okay, well, essentially you know, factory built prefabricated sections, modules, whatever. You drop them onto the site, and you're pretty quick to assemble things. That makes a lot of sense. It's for the higher end homes, it doesn't work as well because everybody wants a custom Dornier window or some other thing like that. It's kind of a one-off thing, but
Yeah,
if you're putting in a lot of housing for, say, a good-sized subdivision or something, this makes a lot of sense. You know, for your run-of-the-mill average home, you know, with the 2.5 kids and the puppy and the whole bit, right? So
that wasn't the case with us. So in the back of the plant, we were building condos, so we knew exactly what you said. We would be pretty restricted if we couldn't design our walls and floors to build anything. That's why I showed you the video. We were able to build anything. We would build developers and floors that had already designed their walls and floors, like the hotel, and that was a seniors home, that's 16-story, and we did completed building. So we weren't restricted on how the unit became.